Sir, I have one doubt actually. Can
Yeah,
I?
good.
Sir, like regarding that C++. So in C++, like interface and abstract calculus are the same, right, sir?
Yes, yes, right.
Only Java has differentiation, right? Because Java doesn't have this multiple inheritance. It is using interface, right?
Yes, yes, right. So you have a concept of pure abstract class in C++. Interface is a pure abstract class.
Okay, which is having that virtual void function.
Yes,
Okay,
yes, absolutely, absolutely. Right.
okay.
See, also the concept is important, and how it is implemented. You may choose different ways to implement it, because again, these patterns, they can be implemented in different programming languages, and in the same programming language also the same pattern could be implemented in different ways. And what is also important is you appreciate and understand, you understand the problem, you understand the solution, and take it just as a case study. Because in real world, sometimes you may have to mix the patterns also. So that way, in real world, in production environment, when you will be working in projects, you'll not be able to clearly see the different pattern implementation. Sometimes multiple patterns might be mixed together, and some implementation is there. But yes, if you understand the concepts, you will be able to understand the reason behind why this is done in a particular way. Right.
Right, sir.
Great, great. Sure. So let me, let's start now. So we were discussing the pattern, which is called the bridge pattern. So we covered various patterns. I'll be covering the remaining patterns today. So pay attention. Today, it's very important class. We will be covering many patterns, and I'll be little bit covering them in a faster way, so that we are able to see them all, and we are able to understand them all. And into details we may go when we will be doing some case studies. We will be solving many low level design questions and many high level design questions. So if I'm not able to go through all of them in enough detail, just be patient. In next coming classes, when we'll be covering various case studies about real interview question, how to answer low level design questions and high level design questions, we'll be covering them. Great. So let me give you some background. Okay, let's recap few things which we studied. So we studied bridge pattern, and bridge pattern is about separating an abstraction from implementation. So that's one I know that's one liner definition of the bridge pattern. Right, so this is about the bridge pattern. So here it is about separating the abstraction and separating it from the implementation. Yes. So this helps because the classic example I'll give, if you have say classes, for example, here you have shape class, okay, and then you have various classes like circle, square. Simple example, because this is everyone understands this. Now if I ask you to write class for red circle, red square, blue circle, blue square, so then this becomes tricky. Your classes, number of classes will grow a lot exponentially, because then I will ask you to implement black circle, all the colors. So you would like to create all these separately. So what you do is you abstract the abstract the things which varies, right? So in this case, maybe you have a shape as a different abstraction and color as a different abstraction, and you have the properties which is you vary them separately. So you have here shape is a circle, and shape is circle is a shape, and square is also a shape. And the same way, you can create a hierarchy about colors, red color and blue color. So this is again another set of classes, and you have always implementation of this. So blue is a color and red is also a color. Now, if I ask you to implement red circle, that is now easy. You will have a shape contains color. You may say that this is a
Tarun, color is interface, right?
this is a bridge. Yeah, correct. Nice. So yes, this is actually the concept here, right? So you have a composition. So you have classes, you may have in interfaces based on the situation, but yes, understand the pattern. It could be anything, interface, classes, abstract classes, but the concept says separate abstraction from implementation.
So one doubt here, can I ask?
Yeah, go ahead.
So if suppose some shape doesn't, we cannot color, and in that case, we have a composition of that color interface in the shape base class, but that shape we cannot color. So we can like in the color interface we can put like not colorable some API, right?
Yes,
That's how
yes.
we can handle that, right?
Correct. Yes. So see,
Oh,
color here, we have the containment. So here, this is just one example, just to help you understand, right? In case there are different situations, you have to think about what could be the way. But yes, if you have an interface, you have to implement it. And then you will get into another problem, which is, right, which principle is violated if there is a shape. So in my example, shape has a color, right? If you have a shape like which cannot be colored, then if I put this interface, which principle is violated? Can anyone tell? Because assume there is a fill color method in the interface, then I don't have to, I have to provide a empty implementation, right? A dummy implementation, because if I'm making something as an interface, it has to be implemented. There is compulsion that this has to be implemented. If I am putting empty implementation, then interface segregation principle is violated, because we should not have such interfaces which we do not want to implement. Probably we have to rethink about the design. So generally, this is one principle, which I'm just giving this example so that you recall the solid principles as well.
okay.
So
So ideally we cannot have one implementation saying like you cannot color this, right?
you can have. See, always there is a trade-off, right? So always your design decisions will be based on something you will prefer than other, right? So
Okay.
yes, I'm not passing on any judgment based on the real scenario. It's very, with less requirement, I cannot tell you what would be the exact implementation. You also always practice this as an architect. You have to design things only after you have complete understanding of the requirement, right? With half requirement, you cannot design anything.
Right. So right. Got it.
So right? So this is all about the pattern. So this is the bridge pattern. Now let me move on to next pattern. Next pattern is the composite pattern. Actually, this is another pattern, which is composite pattern. Composite pattern, how can we define? See, composite pattern. Composite pattern is a pattern where you have a objects. We have a lot of objects. See, this is again, I'm talking in continuation to bridge pattern. Composite pattern is very similar to bridge pattern, or bridge pattern is using composition, object composition. You would have also encountered this pattern in many examples while you would have worked on various projects. So classic example is generally if you have worked on some UI framework like Swing or MFC, you get this classic pattern, which is composite pattern. So composite pattern says object is composed of parts, right? So basically you have an object parts relationship. And with the help of composite pattern, you can create complex objects. So you can, this pattern is about creating complex objects, right? So basically you create complex object structures by combining smaller objects in a recursive manner, right? So this is another important thing. So one example, classic example of recursive manner, you may be asking, what is recursive manner? It's like folder structure, right? So a folder can contain another folder and it can contain file, right? So this is a recursive relation because you can have folder, then another folder, and to any level, right? So this is a recursive pattern. You see this in file system, composite pattern, right? This is one example of composite pattern. Other example of composite pattern is you may have a UI. In the UI, you may have various panels, right? In the panels, you may have various components like button, right? So you would have seen that many operations which you perform on button can also be performed on panel or frame, whatever you want to call it. You may call it. So I'll say frame. Yeah, this is based on different UI section implementation. They may have different naming, but yes, this may be called window. Yeah. So when you create a UI, you use composition pattern because there may be some methods which could be, say, repaint method, right? Or refresh method or draw method. This pattern you may apply at the window level, you may apply at the frame level, you may apply at the button level. So this is about composite pattern. So here, what is important here, that all the parts are sharing common characteristics. So here, important thing between is the parts share common characteristics. Characteristics means behavior. I should say behavior, right? So I'll just remove this. Behavior is important here. Common behaviors, multiple things could be same, right? And then the other advantage you can get is it allows you to manipulate group of objects, right? Rather than individual objects. So that's another benefit you get from composite pattern. Yeah. So for example, when I can say remove some section of UI. I may remove the entire window. When I call a remove method on entire window, that will also call recursively remove method on all the parts. So when window is removed, the frame is removed, the button is removed. Everything which is contained within will get removed. So this is another important design pattern.
So Tarun, they are all connected, right? You mean?
Yes, right? Folder, you use it every day. So they are having the part and object part. They are basically parts, right? Yes.
Tarun, class diagram for this?
Class diagram for this? Sure, I can give you the class diagram.
Because I just curious about, is there any inheritance between the classes?
Inheritance is there, composition is also there, right? Composite, that's why it's called, because there is composition, yes. And inheritance is there because you may have different kinds of components, right? So let me give you the class diagram. Just think of how would you represent your folder structure, right? So you have component. Yeah, I may call one thing as a component. You may have different kind. There are two types of components. One is the leaf component, right? Leaf component is the lowest level component. For example, file. Within file, you may not be able to implement anything, right? And then there could be another kind of component, which is non-leaf component, or you may call container component, or you may also call it composite, right? So since we are talking about composite, I am basically using a term called composite, right? And a component, let me take the exact sample, because here this is the composition. So component is containing is consisting of parts, right? So this is actually basically, this is your container. Let's also call it container, because that's easier. Yes. So what it has, when you have a non-leaf component, that means you have a children. You may have array, lot of children. There may be lot of children. So this is your list of children, and this is of type component, right? All children are of type component. So this is one part. Leaf do not have any children. And in this, right, let me say.
Container should have children of container, right? Container should have children of component or container.
Interface. So component is an interface. It may have some method, which could be, say, execute method, right? Some method. It does something, assume same. We have a UI. So you have an interface, which is a common interface, which is implemented by all the containers, right? So this interface is implemented by container. That means this has an execute method. right? And leaf is also a component. So that means leaf also implements. So let me put this as a dotted line. Yeah, because it's a implementation of interface. And this also is implementation of interface. So yes, this is your, but yes, definitely leaf will also have execute method. So yeah, so this one is your execute method, and it will also implement, since it's implementing, you have here, okay. Container has this list of children. It may also have some more methods, which is say add, remove, right? Remove, this means remove children, add children, etc. And definitely get children. You may have different methods here. So this is about the composite pattern. Now let's talk about another pattern, which is the next pattern. Let me see what we should cover. Let's cover the flyweight pattern. See, these are all structural patterns. So this is defining the structure of objects. So composite, bridge, adapter, these are all structural patterns. Now, next pattern which I'm covering is called flyweight pattern. Right? So flyweight pattern is a simple design pattern. That is, you can think of that the main objective of flyweight pattern is to reduce the memory usage of any complex object, right? So the main purpose is reduce memory usage. How do you reduce memory usage? Is by sharing common data, yes, between multiple objects. So if you have a lot of objects which share some common data, you may apply this pattern, which is flyweight pattern. Yes. Basically, what you do here is you define the state of objects, right? And basically, few things you will have which will vary per object. Few things you may have which is common and which is shared, right? So what you do is you define is state. State could be two kinds of state. By state of the object, I mean this is the properties of object. Yes. So when I am talking about properties of any object, so there could be two kinds of property. One kind of property is the internal property. Other is extrinsic or external property. So always when you are building an object, think of what are the internal properties, what are the external properties. So let me give you an example. Assume you have a text editor, This will help you understand it, right? And in the text editor, probably you may have a lot of text, and you have different fonts also, right? So font is something which you can share across multiple documents, right? But the text is something which is separate, unique for each of the document. So assume you are storing multiple documents. So let me draw some documents. So it has some text ABC. It has some text XYZ, right? Let's say both the text are, this is using font which is say Arial, right? This is also using a font which is Arial. So what you can do is you don't need to store the font information separately. You can use the font, you can store the font information in a common place, right? So what you can do, you can store the font information in common place, and this can be reused by all the objects. Same you can do with the size of the fonts, right? So you have various properties, but yeah, some data you can share across multiple objects, some data you may not be able to share. So characters are different, so you cannot share it, but fonts are same, and maybe some information like font size is also are same, you can store it in a common place. This will reduce the memory. So this is all about flyweight design pattern. Sometimes we apply this by default, right? Say, for example, when I created chess space, I'm storing the type. But yes, color is something which is separate. I need not have to create black knight or white knight. So you can apply this to create objects which are sharing common characteristics. So even different kind of pieces will also share common characteristics. For example, all the pieces are white. Yes, so you can store one common information, need not have to store separately for each of the objects. The color and many other properties you can share. So assume you are creating a game where you have multiple kinds of trees, right? So when you create a tree object, maybe branches are same, maybe the tree has same behavior, but they are different kinds of trees. So maybe the shape of the leaf and fruits which are there in the tree is different. Many other things you can kind of reuse. So this is about the flyweight design pattern. Not complicated, not very complicated. Next, let's talk about decorated design pattern. Anyone has seen in use the flyweight design pattern? Just feel free to share if you are using these patterns by yourself in the project. So who will explain what is decorator design pattern? Anyone knows decorator design pattern? This is also very common design pattern.
Yeah.
You okay? Go ahead. Yeah.
Yeah, I will use the example from head first design pattern.
Okay.
We have a coffee shop and we have different types of coffees.
Okay.
Mocha.
Yeah.
I forgot the coffee names. There are some basic coffee types. Espresso,
Right. Espresso, mocha,
mocha, cappuccino. Yeah. And we have some decorators in the sense like extra cream, extra sugar,
Yes.
like that, extra milk.
Yes.
So these are the decorators, and
Yes.
we have basic commodities and we have decorators. And if we have to create a class for every combination, it will lead to many classes, right?
Yes. Yes. Absolutely.
So we will create a class for all the commodities, and for every decorator on demand, we will decorate the commodities with the decorators.
Yes. Yes. Absolutely. Nice. Nice definition. Right. Great with example. So let me add some key points here. So what is important here is you have same interface, but you have to perform some added behavior. Right. So sometimes you have very similar objects, but some objects do some extra. Right. So again, this pattern can be implemented in two ways. One is aesthetically or dynamically. Right. So at runtime, you may decide something additional you have to do, or at design time itself, you can design something additional you have to do. For example, in this case, you know at the design time that whether the coffee is cappuccino, mocha, or espresso, right? So what I mean by design time, you know beforehand that the coffee is going to be mocha or espresso or cappuccino or latte, right? So there are assumed many kinds of coffee. Yeah. So actually, mocha is the integrant. It is called cafe mocha. Yeah. Because you have to add mocha. Yeah. In espresso, you have coffee, right? You just have the coffee bean. Let me draw this so that it's clear. So it is what is espresso? Hot water and coffee, right? No sugar. But when you have latte, latte is again same. Hot water, coffee, plus milk, right? Yeah. So this is latte. Cafe mocha is, I'm not an expert in coffee, but yeah, let's assume the cafe mocha is same thing. So let me draw this as a cup also. So yeah, this is your cup. Yeah, this is a coffee mug. So let me draw this also, make it cup. Coffee mug, yes. So yes, one good question, right? One aptitude question. Which side I should put the handle to the cup? Yes, anyone? Which is the right side for a mug to have the handle? It should be here, here, or where? Anyone knows the answer?
Wherever it was there, we will rotate and we'll pick it in from the right hand.
Yeah, but yes, what side you have to put if you have this cylinder ready, but you have to attach them.
There are no left and right side for cylindrical.
Yes, right. See, answer. I'll give you the right answer. Right answer is the handle should be outside the cup. Yeah, it should be in the external area. Do not put in the inside. Yes. Correct. So that there's only one wrong answer, which is if someone says, no, we'll put handle inside, that is wrong. Otherwise, it should be outside. Yeah. So yes, now coming back to the topic. Here you have hot water, coffee, milk, and mocha. Yes. And cappuccino is a different variation. Yes, maybe the percentage varies, okay, or whatever. I'm not going into that detail. But what you can have is you can have an interface. So you have a coffee machine interface here. Coffee maker, whatever you want to call. There is a common interface. Now, assume this makes espresso. This espresso is the first one. Yes. Now, so that means it has some methods, right? So methods could be add water, add coffee, right? Something like this would be the interface, right? And yeah, hot water, you would say, yeah, because cold coffee would be another variety of coffee. But yes, now you have to reuse this and create a new functionality. So what you can do is you can create another class which is called latte coffee maker. How can you reuse? Now, any idea? How will you reuse latte coffee maker? You have this, you have a wrapper outside. Yes. This basically. This you can treat as a wrapper. So you can assume there is one method, which is a make method. Make method, what it does, it calls this method first. First it calls, yeah, maybe first it adds hot water and then it adds, right? So it adds then the coffee. Yes. So it does one by one. So now what you will have again here the make method. So you have the make method, but yes, you may have this as a decorator. So what you do is you add milk. This is something additional which you do. You call this and then call plus espresso coffee maker dot make. So this is your plus means it's a new statement, right? So this is your decorator. Yes, so you are reusing the same, but you are doing some additional decorator using additional decorator. So this is the decorator pattern. Basically, it's a wrapper and it adds one more functionality on top of the existing functionality. Same way you can add different decorators and you may get different kinds of behaviors. So this is all about decorator pattern. So it's again a simple pattern. Now, since we have done so many patterns, so these new patterns are looking simpler. And basically I will say, yeah, structural patterns are easy, not that complicated. Easiest is the facade, then flyweight. Then there is another pattern now. Let's talk, go ahead in continuation. And hardly there is very little difference between all these patterns. There is a pattern called proxy pattern. So proxy pattern is basically a pattern where you can create a proxy object which can act as an intermediary between some operation, right? So either you can add a decorator to enhance the functionality. Here, proxy pattern is all about you are probably controlling the access, or probably you are adding or modifying something by having an intermediary object. So let me explain this. Anyone wants to explain this proxy pattern? Who will tell? No one? Funny, you want to speak out what is proxy pattern?
Actually, Taran, I am very new to the system design, so I really don't have experience, working in developing job.
Okay.
Yes. Thank you.
So let me explain what is proxy pattern, which I will explain with a real life example. In programming also you can apply, because object-oriented programming is very similar, very close to real life, right? You would have heard about this. So assume you want to make payment. Yes. So payment is done via cash. Right. So, but what is a proxy for cash? We can use a proxy, right? So payment has one method, which is pay. And you input some floating point number, which is amount. Yes. So probably this is a interface, because you may have different implementations of this. Better keep everything as an interface, because now if you are wondering what is a use of having an interface, always while designing, put things as interface, because you may ask your developers to write just an implementation. Right. So this is your implementation, right? But what you do generally is cash payment, but proxy for the cash could be. So there is two ways to pay. One is via cash, right? But other way is paying via credit card. So your credit card is the proxy for the cash, or basically cash. This is your account balance. Yes. Cash, what do you mean is what I exactly means is you are paying by your account balance, but proxy cash credit card could be your proxy. Maybe your bank account website is down, but credit card will be able to pay because it has a limit. So it has some additional information. It can have some additional security checks. It can verify the service to which you are paying, right? But when you are paying manually by cash, there is no way to do some verification. But when you pay by credit card, everything is recorded. So this is kind of a proxy. Right? So this is about the proxy design pattern. So basically, what is the implementation of credit card is maybe you have the pay method, very similar to decorator pattern. But in the pay method, what you do is you first say check credit rating, right? And then you do the payment, right? So this is what the difference between. Yeah, maybe this is just an example. Maybe there could be many checks and lot of things you can do, but yes, you are using the same operation, same interface, but you are adding additional value, additional functionality. You may also provide some additional behavior or enhanced behavior, similar to decorator pattern. Right? So now are you all clear, Suresh, with all the patterns so far? This completes all the structural patterns. Right? So what all we covered, I'll just give a quick recap. Adapter pattern. Adapter pattern is for different interfaces. Yes. And what you do is you wrap the different interfaces and make a adapter which can translate the interface and convert the required messages into appropriate interface format. Then we saw the proxy pattern, right? So proxy pattern, see here, there is a contrast. In adapter pattern, when you have different interfaces, you use adapter pattern. Here you have same interfaces. So that's important difference. And see here, interface is exactly same. Now in decorator, you have enhanced interface. So these are important difference which you can note down. Then we discussed some patterns which were like facade pattern. Right? So facade pattern is about hiding the complexity. Yeah. Actually, this is about simplifying interface. So here. Right. So, and then we saw also other patterns like composite pattern. And decorator pattern. Okay, composite pattern we saw and flyweight. Flyweight pattern. Which is about saving memory. Composite pattern is about parts, building objects using parts, and here saving memory. And then we had a bridge pattern. Bridge pattern is about separating or abstracting, basically separating interfaces or separating abstraction from implementations. Right. So this is all about different design patterns, creational, structural design patterns. So this is all about structural design patterns. Now let's move on to the next set of patterns, which is behavioral pattern. And as I said, behavioral patterns are patterns which will be, I will give you example here. So we discussed there are 10 behavior patterns: strategy pattern, observer pattern, iterator pattern, state pattern, visitor pattern, template method pattern, and memento pattern, command pattern, chain of responsibility pattern. So these are different kinds of patterns. So let's talk about, in general, the behavior pattern. Okay. In the behavior pattern, let me talk about observer pattern, because I'm very sure that you guys would be knowing what is observer pattern. So who will tell you? Who will tell me what is observer pattern? Arun, just one comment. Arun, your name has changed to capital letters. You have applied some decorator pattern.
No, actually, I'm
Yes.
going for dinner. So till now, I was connected from my laptop.
Okay.
I just switched it to my mobile. So
Okay.
dinner will be ready at 9 o'clock here in PG.
Right. Okay, nice. So you have a proxy, mobile and laptop. So while eating, you will use the proxy pattern. You'll have the enhanced functionality, attending the class as well as having dinner. And
Yeah.
otherwise, you will use the core implementation, right? So
Yeah.
good, nice. Awesome. Yeah, go ahead. Funny, you were talking about what is observer pattern.
Yeah, actually, Tarun, I really don't know, but I guess observer pattern is something like which observes is there any, if there are any mistakes, maybe it will find out.
Yeah. Okay.
Yeah,
Okay.
can I tell?
Yeah, go ahead.
Yeah. We have some, it's like publisher subscriber model. We have some subscribers and there are some publishers. Whenever publisher publishes some thing, then it should notify all the subscribers.
Yes, absolutely right here. So you have basically a lot of interested parties, which are called subscribers, right? So you have various kinds of subscribers, subscriber 1, 2, 3, and there would be publisher. Subscribers are also called observer. Yes. And publishers are also called producers. So there are various terms. You may call consumer also subscribers, and you can call the other one as publisher, or you can say producer, right? So this is about the pattern. And This is all about sending updates. So whenever there is an update, so you can think of that there is some channel or topic. Here, there are some updates. Updates are done by publisher and notifications are received by subscriber whenever there is a update or some event happens. So notification will automatically go to all the subscribers. So this is all about this, the pattern. This is all behavioral pattern. So you should see that this is how the behavior is happening. Yes. We'll come to that in this detail. Okay, let's talk about it in detail now. Because other patterns are very simple. Many patterns are simple. So basically what you have is, you have a class, which is, you have two components. One is your subject, other is the observer, right? So basically I'll write two classes. Subject or topic, I may call this as a subject, or I may call this as topic. In this subject, I have some state, right? Say, let's say we have some value, which value could be, say, you are looking for temperature. This is weather forecast application, or it could be stock price application where you're checking the stock price, right? So you can think of this is the subject. Now there are many applications which are interested in this. Say, let's say you have a lot of sites, for example, maybe flight or airline sites, right, are interested in this. Similarly, you may have other objects also which are interested in it. Say, for example, maybe agriculture, right? These are different objects. So in addition to the value, what you also maintain is, you maintain list or array of subscribers, right? So in this case, it is, I will call airline and say farmers, right? These are my subscribers, right? So let me rename this for simplicity, airlines, and instead of agriculture, easier name, farmer, right? So these are my subscribers. So here some methods I will also have, which will be a method which will be add subscriber. So definitely, and then you have notify method. So whenever there is a change in the value, I will go through my subscriber list and I will notify all the farmers. So this is all the subscribers, which is whatever is there in the list, right? So you also have add, remove subscriber. So these are the methods which you will have. As you are adding a subscriber, you may also remove subscribers. So you'll do add, remove subscribers, and there will be a notify method. Notify method is, assume they have also this temperature value, right? So here, assume you have this temperature value. So notify would be nothing, but they will update the value here in the object. Farmer.temperature will get updated. Airline.temperature may get updated. So notify will take care of going through the list in loop. And for each of these objects, it will be calling, modifying the temperature value. So this way, if there is a change in one topic, you may notify multiple observers or subscribers. Now I'm going to the state design pattern. See the name actually, if you are familiar with, and what is the purpose, half of the thing is done, because in low level interview question, you may not have to draw the entire diagram. Because if you confidently tell to the interviewer that I will use observer pattern or I will use subscriber pattern, automatically this is assumed that you are talking about creating a subscriber list. You are talking about adding and removing subscriber methods. And you are also talking about notifying, calling the notify method, and which will update all the subscribers. It will have a loop and it will go through all the subscribers and it will update everyone. And you may also call add and remove subscribers whenever you want to add new subscribers or remove new subscribers. And later, the notification will always work as per your subscription list, subscribers list. So this is all about the observer pattern. Now, next I'm talking about state design pattern. I'll give a common example. Assume you have an object which is say the login page, right? So this is good example because see the example of login page. So assume you have a state design pattern. A state design pattern, that means there is a state. A state is nothing but a property. For a login page, there could be two states. One is sign in. Other one is sign up. Right? Anyone knows the difference between sign in and sign up?
Sign in means basically we give username and password, right?
Yes, right?
Sign up means if you are very new to the website, we need to,
Yes,
register. Yes.
Awesome. Great. So here, see the object is same. Here, when you have the state as sign in, you have the login form, which means you have username and password. Right? This is what you get. So this is when state is sign in. But when state is sign up, same object, but behavior is modified. Maybe here you will get some changes. So here you have, instead of login, register button. And maybe you will get another dialog here, which could be confirm password. Right? So this is a classic example of how to apply state design pattern, and various scenarios could be there. This is just one example. You may have a lot of examples where based on the state, you have to update the behavior. So this pattern is useful when you have a situation where behavior of objects needs to be changed based on some state, right? So what actually happens in the background is you may have a context field, right? So for example, in servlets, many server-side application, you have a context field. And based on the value of the context, you always have a reference to the context object. And based on the value of the context object, you will enter new state. and you will have some behavior which is dependent on the context of the object for the specific state. So this is about state design pattern. Now let me talk about another design pattern which is also very popular, which is a strategy design pattern. So in a strategy design pattern, yeah, who will tell what is a strategy design pattern? No one has idea about strategy design pattern? So here main thing was state. Sometimes you may apply multiple strategies, right? So as it says, that means you have various algorithms which you may apply. So assume you have a class which is called sorter, right? Let's call this number sorter. So what you should do is you should create an interface which is basically the sorter, number sorter should be an interface. And it should have a sort method, right? So sort method will accept array of numbers, let's call it numbers, and it also returns integer array, which is the sorted list, right? Or you may have an in-place sorter, which may just sort whatever is input and it prints or it kinds of updates the existing list, right? So let's say this is your sort interface. Let's keep it array. Now there are different ways of sorting, right? So you may implement each of these sort methods differently. You may call one as, let's say, bubble sorter, right? Maybe this is one algorithm. You may have different implementations for the same object, insertion sorter, right? And so many, and you may have multiple strategies here. Everything is implementing the same interface. So you can very easily replace, because you always program to the same to the interface. Yeah. So this way, when you will write the client code, you may write client will create new. Basically here what you will have is, let's talk about here, new number sorter, okay. And here, let's say if maybe user can choose by providing some value, say there is input equal to, say user types bubble, right? Then what you can say, sorter equal to new bubble sorter, right? And then you will say nums dot sort. This is your final implementation. Same thing you can do if input equal to, this is your check, right? Equal to, say user has insert So here what you can do, sorter dot new insertion short, right? And then you say nothing. Yeah, the same code will work. So this code, you have to input the strategy and just create the appropriate object. This code you don't have to change. Polymorphism is coming into picture, and this is happening dynamic binding. Input can be dynamic input, and based on it, appropriate algorithm will be applied. So it's strategy better. You may also think of, say, for a large set of numbers, quicksort is there useful. So you may have some condition that if my numbers dot length is more than 100, then apply quicksort. If it is less than 10, apply insertion short. So here you can use various strategies. So each algorithm is encapsulated in its own class. And you get greater flexibility and maintainability in the code because you don't have to change this part. This is just an example. This may have a lot of code, but what you only have to take care is this part. This part you don't have to change. Maybe your logic is changing. Tomorrow you say if less than 20 items are there, then I'll apply insertion short. Yeah, you can do it, but just you have to update this condition. This thing will remain same. So this is more maintainable code. So this is about strategy pattern. You have to tell in the low-level design interview what patterns are using. You have to throw them, be fluent with all these terminologies, pattern, design pattern names, and know the purpose of each of them. Yeah, use the recording. This recording will be useful for you to revise a lot of content. So now next I'll talk about template pattern. Email template, right? This is similar to template pattern. Anyone want to explain what is template pattern? See, template pattern again is behavioral design pattern. Behavioral design pattern is all about designing the behavior, or it's about deciding about how to perform some operations. So here, what you will do is you'll have a base class, which is your template class. Right? So let's say we have a logging interface. So in logging, you do extraction, let's say, or I will say ingestion. This is about log ingestion. Then you transform the data. So transformation, right? I'm just referring to, this is an example which is ETL kind of example, right? So ingestion, transformation, and finally, what you do is maybe aggregation. Right? So you have some operation which contains different parts. But here, each of these parts may contain different multiple strategies. But overall, the template is you do first the ingestion, you do the transformation, and then aggregation. So you basically have is step 1, ingestion. Step 2, transformation, or you may have other steps also, maybe data cleansing or right cleanup. Classic example is unit testing. When you write unit test, you use this template pattern. Yeah, that would have been even a better example. So what is the template in case of unit test? Who will tell me? Who has worked on some unit testing framework? They follow template method pattern. JUnit, for example. You have setup, right? Then you have before and after method, right? Then you have test method, and this you have after method. You may have cleanup also. So these are the steps which you perform for unit test. So you have a template here. So this is the template method pattern. Right. So this is for unit test. Next, I will cover visitor pattern. Making sense? You guys are getting what I'm talking about? We have covered so many patterns. Am I in the call? Right. So are you guys listening?
Yes, sir.
Right? Clear, or voice is clear, right? So in
It's clear.
visitor pattern, you again separate out the algorithm by having a visitor interface. So basically, yeah, let's talk about, there is an algorithm, assume, which is calculate your salary, right? Maybe gross salary, how to calculate. So the way you can do is, you may create a visitor interface and you can say that there are different kinds of object types in the salary, which is components, right? But what your visitor pattern will do, it will have an interface, say add, right? And you have salary components. So what will happen is, assume your salary is again, what pattern you will apply? It's a composite pattern, right? Salary is always a composite thing because it will have various components, right? And you don't want to have a fixed structure. So you may have components. And then this component is a class. Yes, it may have object. Component may have various kinds of objects. For example, base salary, bonus. Yeah, it may have bonus, or it may have commission, HRA, LTA, a lot of other components could be there based on different employees. You may have different components, right? So these are composite pattern. And your visitor here, visitor interface will visit all these components. It will add all these components and calculate your final salary. So this is all about your visitor pattern. Visitor pattern is just having the separation of objects or components and then performing some algorithm separately on individual objects is all about visitor pattern.
Tarun, could you please repeat the visitor pattern again?
Right. So let me write here also. This pattern is about separating algorithms from objects they operate upon, right? So I'm giving an example of gross salary calculation. Assume this is a HRM. Now, one way is, yeah, you will say, okay, I will create a calculate gross salary method. Again, I will give my classic example how the software engineers will do. They will just say, yes, I will have various component, which is base plus performance bonus plus maybe if commission is there, that plus HRA plus LTA, right? I'm done. So you say just return this, I'm done, right? They'll say, wow, such a simple code. I've completed the task. But customer tomorrow comes, he says, add more component. You will add one more component. You have to modify the code, release another version of the software. Then you will have new. Say, for example, we got some health benefits, right? So tomorrow some other benefit will come. So you'll keep changing your code again and again. But how the senior software engineers will do? Same thing. They'll apply the visitor pattern. They say that they have a visitor object. Visitor object can go through all the components, salary components. And salary is a composition of various components, right? They'll write a lot of code here. So yeah, what they will have, say, they may create salary components, right? And then in these components, they will have various components and they'll define a visitor pattern. The complex concrete implementation, this is an add method. So now what will happen is calculate gross salary. Basically, what they will do is they will have a implementation, say visitor IMPL dot add, and in this add method, probably they will operate over all the salary components, right? So here probably they will pass salary or components. I have called this components, right? So now the advantage is they will populate the components, right? And accordingly, the salary is always returned. Right? I'm just giving you simplified example because real complex code I may not be able to write it quickly here. But yes, you see here that is the more maintainable code because there is a visitor will be adding it, and basically assume visitor implementation is you have a gross salary. You keep adding the amount to the gross salary. So this way you will have a more maintainable code, because you may not have to change many components. You just add one more component and you get the salary calculated. So this is about creating a visitor pattern and separating algorithms from the object they operate upon. Yes, so in this you have a salary class, and in this salary you had the object on which it operates, which is base, bonus, commission, right? All are of, say, float time. But in this you have separated, partitioned the visitor, the component. So visitor contains the logic part. Logic is in this case simple addition. So this is how that visitor pattern works. Understood?
Yes, Tarun, I got it.
Yes, because when you apply it, you will understand better. But at this amount of time, you should be just knowing it. So now I will cover one more pattern, which is also very similar. This is called iterator pattern. So iterator pattern is, you would have used it if all the Java developers, they would have used, because in array list or linked list or hash chat or any kind of data collection classes, you have a iterator. Iterator is a pattern which is about traversing through the collection and performing some operations on each element, and iterator provides an abstraction of how to iterate on items. Basically, internal structure is hidden. Yes. I'll give an example here. So this is, now I said visitor pattern will go to each of the components, and your components are stored, assume, in array. So it's very simple. You will go to first item, then next item, and going forward, right? But if I say the components are stored in tree or a linked list, then you have to take care of visiting the next node, right? In tree, you have a different way of traversal. When I say in order traversal, then you have to decide, now I will visit root, then left and right, right? So this is pre-order traversal. If in order, then left, root, and right. So you may have different ways of iterating to different kinds of data structure. But yes, what iterator pattern says is, you abstract these complexities, you just have the next method, right? Assume if we have just the next method. So generally in Java, what you have has next method. It shows whether there is a next element or you have already reached the end, or you have a next method. And when you call this, you get the next element. And this works in array, in linked list, in tree, in hash set, because each of these collection has a different implementation of this interface, which is iterator interface. So the advantage which you get is you can replace an array list with a linked list. Your interface is same. So you can just change the data structure, the algorithm, your code will always work. So that is all about iterator pattern. Clear? Now I'll move to next pattern. See, if you look into the Java library or C# library or JavaScript library, you will find examples of all of these patterns, right? Right from singleton. Singleton you will find in some big frameworks and many other patterns. Composite pattern, as I said, is there in the UI Swing library or various UI. Most of the UI libraries implement composite pattern. Iterator pattern you will find in the collection classes implementation. And similarly, some are found in, for example, prototype pattern. We studied, remember, a creational pattern, which is called prototype pattern. You will find in all the objects, because you have an object class and it has the clone method. You can clone any object in Java. Yes. Builder pattern, you will also find string builder is there, right? A string builder, you can append more strings to the existing strings and get a bigger string. That is a builder pattern. You'll get a lot of examples. Now, if you look around and after knowing all these definitions and concepts, I am very sure that you will be able to find hundreds of examples of all these patterns. And when you look into the examples, this will enhance your learning and will make you more confident, and you will be fluent in using all the patterns. And next time, if I give you any problem, you will be able to tell me that these are the patterns I'm going to apply. And you may also apply patterns in combination, because in real implementation, as you would be seeing, I have also given example. Here I have used composite pattern for salary, visitor pattern for adding the visitor. Maybe if I want to say generate the payroll, what you call payslip, I may call iterator pattern, where I will iterate over all the salary component and print it in the payslip. So that is an iterator pattern. State pattern also you may apply. If an employee has maybe performance rating this, you apply bonus. If less than say 3, do not add bonus. So you may have state pattern also, depending on the state or depending on the designation. You calculate different percentage of bonus and add it to the salary, right? So this is a state pattern also you can apply. So in real application, better to apply multiple patterns, and this way you can make your code very maintainable. Definitely you have modularized it, so you can also separate the responsibilities to different team members. This way you may also scale the development. Now let's talk about another pattern, which is called, and also remember the sequence in which I'm teaching all the patterns. That is also important because it is in the flow. Next pattern is chain of responsibility. Yeah. Because I have ensured that when I'm teaching all the patterns, I am teaching in a logical sequence so that you can understand and you can differentiate between different patterns, and you will also understand what is better in this pattern, what is not there in the previous pattern. So yes, with the pace with which we are going, it looks like, yeah, we'll be able to cover all the patterns, because there are three more patterns which are remaining. Yeah, I'm just checking. Yeah, are there 3 more patterns only? Yes. So let's talk about chain of responsibility pattern. So chain of responsibility pattern is what you do is you handle the requests. So basically you create handlers, and you may pass multiple handlers to process an object at runtime. So this is about chain of responsibility pattern. Basically, yeah, I have already given you one example, which is template pattern. But here there is difference here. It's similar to template pattern, which is also about having steps. But the steps are static in template pattern. Template pattern has, for example, in unit test, setup, before test, test method, after test, cleanup, right? Here you may have multiple handlers, and you may apply them as per your wish dynamically. And this way, from the same small number of handlers, you can derive multiple behaviors. So, yeah, let me give an example of chain of responsibility patterns. Basically, pipes and filters in Unix is an example, because you can chain multiple methods together, right? So let me give you an example.
So Tarun,
Yes,
in
go ahead.
in the template pattern, you know, it will execute one by one, right? Each method. But
Yes.
whereas in the chain of responsibility, everything will execute it a single time. Is that?
No. In the template method, you have a template, predetermined template. You do first step, step 1 is this, step 2 is this, step 3 is this, step 4 is this. In chain of responsibility pattern, you have the handlers, and you have the freedom to apply any handler in any number of times or in any combination. Yes.
Means in random order, right?
Yes, you can use the handler as per your requirement in any order. Yes. Right. So I'll give an example here. You would have known that there are so many commands, right? ls command, for example, in Unix, using chain of responsibility, right? You can think of that in the background when you are typing something in the command line. Now, what you can do is you can put pipes and filters, right? There is a concept of pipes. Pipes is like chain of responsibility. You can chain. Now, what do I mean by chain? Say when you give an ls command in Linux, ls is a command, right? List directory. List directory structure is the name of the command. So assume you have many directories, which is docs, lib, many, assume, blah, 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 right? Lot of. Now this is chain of responsibility. Now this is a simple command execution. Now let's get the chain of responsibility pattern applied to it. What you can do is you create a method, ls method. You create another method which is called head method. It takes an argument which is how many number of items you want to display. You will get first 5 items here. Right? This is chain of responsibility pattern. I have chained another command by using a pipe symbol. So what it does is it has many handlers. It applies ls method, then head method. I may also apply another handlers. I may say sort, right? And I may pass maybe some file's name, right? By file size or something, I may file another attribute. So now you will get the top 5 in sorted order as per the file size, right? Say, assume, I'm not 100% sure about the parameter, but yes, if I say, right, this, so you will get. So this is a pattern where you can dynamically determine what all operations to be performed, and you can perform them, chain them in any order. Yeah, you were saying something? Go ahead. This is a practical example of chain of responsibility. How will you implement it? You will implement it by creating an interface, which is a handler interface. And you will have some methods in this. Methods could be, one is your handle request, right? It will take some parameter, probably request parameter. And then you will have another method, which is set next. This will take handler. And this is the next handler, right? Something like this will be your interface. And your concrete implementation, you will provide the concrete implementation, and in a handle request, you may be handling the request. Based on the type of the request, you may be handling it. So something like this, you can implement it, and the client, when it will be calling, so this is the interesting part, because calling, how it is getting called in the client, right? So client is definitely is a composition of multiple handlers, right? So, but yes, now you have seen composition so many times. Basically, what you will do, I'll maybe give a code snippet here. You have handler, say handler 1. Maybe we will use the first 2 example, where first handler is list directories, second handler is sort directories, or list the top 5 directories. Now, good thing is this handler could be applied to ls command. It can be applied to other commands also. It is not specific. Same way you can combine 2 handlers and form very nice variety of operations. So you may have handler 1, which could be ls command. You may have another handler, which is handler 2, some other command, which could be, say, delete command or any other command. So you may create new concrete handler, right? So maybe you will have, so same thing you will do for different kinds of handler you may create. you may have handler dot set next handler 2. Right. So this way you will create your chain of responsibilities, and basically this way you will call them handlers, right? So handler, so you have handler 1. Yeah, here you will have handler 1 set request. Then you will say handle request, and you will pass the request. Right? So this way it will be doing handler 1. Handle request means handle the entire chain of responsibility, and it will, because you have set here next handler is handler 2. So when you call this handler 1 dot handle request, it will perform operation 1, operation 2, and then finally give you the output response. Right? You may set multiple handlers also. You may again say handler 1 yeah, you may handle request next handler. You can keep adding next handler and get more modified behavior. Right? So for example, I did this for sorting. So now let me talk about other patterns. So now next pattern which I'm talking about, is this clear? Chain of responsibility.
Yes, Tarun.
Yeah, basically you use it in many places. For example, this is one example, but in UI also it is being used, because if you see the propagation of events in JavaScript is also happening as a chain of responsibility. Yes. If you have an event, the event will be handled in the window. Then next is the next composite component, which is maybe a window has a frame. Then frame has maybe some button. So you have a chain of responsibility. When you say handle mouse click, the event will flow and will be handled in appropriate place. Right? So this is applied in various places. In DNS name resolution also, you can see this example, where you will first find the root domain name .com if it's the root domain name. Then, right, somehow recursively you are handling multiple requests. You are handling multiple requests, and you are passing along the same request against multiple handlers. So next design pattern which I would like to cover is command design pattern. In command design pattern, you will decouple an object that sends a request from the object which receives and executes the command. Right? So let me think of an example about command design pattern. You would have heard about various command objects, right? So one example which I can think of is when you have to create a calculator, right? Assume you have a calculator. In calculator, you have various commands. You have numbers also, but yes, you may have various commands, which is say simple operations, addition, subtraction, multiplication, etc. So what you can do is you can create a command interface and you may have an execute button, execute method within the command interface. Okay, so it has see, I have to give you simple examples because if I give complicated examples, then describing it becomes difficult. Yeah, don't sometimes the implementation you may feel is over engineering, right? Because you say, okay, this is such a simple scenario, I will just say a plus b. But yes, I'm doing the same a plus b using command pattern. Don't think it is an over engineering. This is purposely done to demonstrate this. But yes, in complex scenario, this will be helpful. You will appreciate that in complex scenarios. But that we will cover when we will be doing various case studies, because we have around 10 more classes where we will be doing case studies. Now, all the concepts are covered. Now, only thing which is left is how to deal with various problems in the real interview when you have to apply all the concepts learned so far. So in first 15 classes, we covered various concepts. We also covered some case studies also. Yeah, but yes, 50-50 is what we have done. 50% theory, 50% problem solving, which is absolute right mix, I believe. So here you may create a add command. Add command is the implementation of the command interface. Right. So when I say add dot execute, yeah, that means I'm adding, right? So here you see the command object is being separated out. So what is the flexibility in this? You may say that, okay, why can't I just have few classes? So then you have here difference or subtraction. Let's call it subtract command. Each of these are implementing the interface, which is command interface. Is anyone understanding what is the benefit in doing this command interface? Because I believe having seen so many patterns, you will be able to appreciate that. Tell me, what is the advantage of doing such thing in, say, our calculator class? Right. So here execute method is what? You have the concrete implementation. Here you will do, say, first plus second, right? And then you return this. The interface is same, right? Assume this is returning integer. Assume we only have the calculator which has integers. It's simplified version. But yeah, this is the interface. And here subtraction implementation is very similar. Here. Again, I'll say this is how senior software engineers will do. Regular software engineers, junior software engineers will write simple code. Yeah. So tell me, Arun, what is the advantage of doing this command pattern? You can, go ahead.
I'm not very sure.
Right. See, I can add dynamically more commands. Yes. So flexibility is there. Tomorrow you say, okay, I want modular item, modular button also. I will use the same implementation, add another command, and my UI could be generated dynamically based on how many commands I have instantiated. Right? So you get more flexibility with this. Right? So your modular operation will also get implemented. Next design pattern which I will I'll cover is called mediator design pattern. Is very similar to the proxy design pattern. Mediator, as the name suggests, it comes in between, but yes, it is always mediating. Yes. So example is, assume you have various operations. Files, for example, in file, you have save, update, delete, etc. Right? Operation. Maybe CRUD operation. Basically, you can create a file, you can update a file, you can delete a file. You can read a file also. Yeah. But you can do for a file all these operations only if you have the authorization. In all the operating system, you have this pattern applied. So whenever your client is performing any operation, there is a mediator which will come in between. It will ask you to enter your password if he wants to verify your credentials. Right? So authentication is always implemented using mediator pattern. This is a classic example of mediator pattern. Client will call.
Mediator is middleman.
Yes,
Middleware.
middleman. Yes. Client will always call here, create, update, delete, read operation. But mediator, that operation will happen through the mediator, and this will authorize the operation, and it will perform some additional checks and then only perform the operations if eligible. Otherwise, it may return error or it may ask something. Right? It may prevent the operation.
Yeah, Taran, basically one example is in company laptops.
Yes.
In some company laptops, we can't install some files, right? Some open source files, definitely it will ask for admin credentials, username and password.
Yes. Correct.
This is one example.
Yes, absolutely.
Yeah, Tarun, I was looking into some API code uh, to, but in that API parameter, there is no authentication. I
Okay.
was wondered like where the authentication logic was there.
Yes, absolutely. Yeah.
But as a middleware, that happens
Yes.
using this pattern only, right?
Correct. Yes, it would be happening using this pattern only. Right? Because in some central location, they would have defined the mediator, and all the communication which is happening between the components is going via the mediator. This would have happened. Right? So basically, in somewhere they would have defined that do not communicate directly, always communicate with the mediator. So that is the difference between mediator and observer. In observer, you may only get the notification when something happens, right? And if you are a subscriber, mediator is something like it will always get the notification and it can come in between. And it also has an advantage that it eliminates mutual dependencies. It becomes a middleman. So your components are always dependent on mediator. It is not depending on any other object. It is only dependent on mediators. So this simplifies the implementation also. So we discussed, see, all these patterns are basically the patterns for connecting senders and receivers of request. Right? So basically here client is the requester and this is someone who is processing the response. So when I say chain of responsibility is adding handlers one after the other. When I say command pattern is about having different commands as a different entities. But yes, in command pattern, you apply one command at a time. In mediator, you perform some additional operation. In observer, based on the subscription list, you communicate. Right? Same is the case with other patterns also, no? Few more patterns which we studied: chain of responsibility, iterator, visitor, template, strategy, state, observer. Yeah, these are various patterns. So yes, basically it's all about connecting sender and receiver, mediator, observer, command, chain of responsibility. Command is always one directional, direct communication. So command pattern is basically sender and receiver directly communicating. But in other, proxy pattern was one pattern. Yeah, but proxy pattern was a structural pattern, not this pattern. But yes, these are different patterns which were connecting connecting sender and receivers. Now let's come to the last pattern. All the design patterns are covered after this. The last pattern is mediator design, sorry, memento design pattern. Yeah, because see, the names are, I'm also similar names, so many names, vocabulary, lot of, this is
Tarun,
grammars
uh,
vocabulary. Yeah.
Yeah. Actually, most of the design patterns are like used in the frameworks, right?
Yes.
So more in terms of coding, like there are many design patterns which do not come in coding. But
Yes,
there are like remaining like this mediator and all those things. They come with the frameworks.
yes. Right. See, it will come in the coding because as a developer, you should always develop frameworks. You should think of in product, you are developing a product. Always treat whatever project you are doing, do it as a product and do it as a framework. Framework is nothing. It's a product is nothing. It is not specifically for one customer. You should be thinking about changing requirements. So do it as a framework. Right. So then you will apply it. Yes. But yes, sometimes
Actually, I have one doubt.
over engineering. Yes.
Yeah. Between the product, framework, and library.
Correct.
Library is something which we call from our programming language.
Yes.
Framework is something where the execution starts and it has some convention we need to follow and implement.
Yes. Yes.
And then what do you mean by product?
Right. See, product is a software which can be used by multiple clients. This is a product. Product is again an application, but I would say it is suitable. It can be used by multiple clients. That is a product. You can sell it to multiple customers. If you have one customer, then it's a solution for that particular, it's a custom application, basically, right? You custom make an application for a specific customer is a custom application. But if you make a product for multiple customers, or if you make an application for multiple customers, then it's a product, right? So that's the two things I talk about. Product versus custom application. Clear? Now clear?
Yeah.
So now let's talk about memento pattern. So this pattern is similar to state pattern, but there is a slight difference. You have an object here. You will create a memento of this object. What does it mean? Memento is an object which stores the state of the object. Right? So basically it's a copy of object. Memento is a copy of object. But using this memento, you can create back the object. Then you have probably another, maybe this you can say is processor. Processor needs to work on object. And processor has few interfaces here. One is the history interface. It has, yeah, definitely it works on the object, but it can also, history is nothing, is array of states, mementos in order. And then you will have operations here, which is maybe some method, do something. And definitely you will have undo functionality. So you can create undo redo kind of functionality. So that's the advantage of this pattern. Right. Basically here I should use this sign, which is composition. Because here processor is a composition of history. This is the composition. So basically here. So this is the composition pattern. Now using this, you can always create a history. You can maintain the history of operations, and you can also implement undo redo kind of operation, right? Because you have a history of all the operations you are performing. So assume this is your text editor. So object is basically text. If you are doing any operation on Word document, you have a memento. Memento is your history of changes. So in review mode, when you edit any document, all the operations are saved. That you have added this text, you have restyled some text, or you have deleted that text. Because your object is getting changed, but at the same time, a memento is also getting saved. And your history is there with the word processor. And using the history, you can do infinite undo redos because you have entire history saved. So this is about the memento pattern. So you can call it undo redo or restore operation also. Save restore operation. This is about all the design patterns. Again, there will be different ways of implementing the patterns. So, but yes, this is most simplified explanations with easy to understand examples. Right? So now, are you all feeling confident about design patterns? So we covered all the 22 design patterns. In the next class, we'll move to high level design. We have covered all the low level design topics. So we'll start covering other system design concepts. Right? We'll do various case studies. So any request about what case study should we do? I have an idea that yes, we can do book my show, design of book my show application, which is either book my show or hotel booking, make my trip, or yatra, these kind of applications we can decide, we can do. So yes, IRCTC, book my show, make my trip. This is what we will be covering in the next, where we will be covering both low level design and high level design. And we can also discuss various database concepts. We can also discuss various design patterns and the overall system architecture for these kind of applications, which is book my show, IRCTC, make my trip. You should remember tiny URL we already covered. And now we have also covered various design patterns, and we have also discussed chess example. And so you should be able to do low level design of chess game and low level design of tiny URL and high level design of tiny URL as well.
Arun,
Correct. Yeah.
these three are booking systems, right? Or are you going to explain all the three or any one of them?
Yeah, it is basically, I'll show you one. You will be able to do others because they are similar, right?
Got it.
Correct. So you will be able to implement any such kind of systems because
Sure,
the
sure.
designs are very similar.
Hmm.
Basically, you are booking some seats, right? Whether it is hotel room or whether it is a flight ticket or it is a show cinema ticket. Yeah, concept is same. Just slight variation is there. So I will share you how to do this. Okay. So we'll be covering all of them, but I will share one and you will be able to understand the rest. Correct. So maybe I'll discuss one, book my show. Others, you can take it as your assignment and you do practice the others as well, because you may get others in the interview. But yeah, if I cover all three of them, that would not do justice because they are having similar design. So I would be repeating all these concepts. So I'll skip to more advanced topics in the next class and leave up to you to do similar designs. Right? Because otherwise we'll be consuming many classes in similar designs, right? So we'll do next Instagram or we'll do payment gateway like UPI or PhonePe, different kinds of app. And then we'll move to YouTube, system design of YouTube, etc., where you will see a lot of more advanced concepts coming into picture. Right, awesome. So have a good night. If no further doubts, just practice, revise these topics, go through, do Wikipedia is a very good resource to learn design patterns, because you can learn about each of the design patterns and the code examples are also there in Wikipedia. You can use that as a reference. It's a very good reference, elaborate reference with a lot of examples. You can use it to learn all the design patterns. Search Wikipedia in all these design patterns for all these design patterns and revise all the concepts which I covered so that you become very thorough and experienced in all these design patterns and you can use it in your day-to-day project or to answer any of the interview questions.
Thank you, Tarun. Have a great weekend. Bye.
Sure. Okay, see you. Bye.
Thanks, Tarun.
Thank you.